Okay, welcome back, Art22. We're just going to have a relatively short lecture today on one method for doing some web-based coding using p5.js. P5.js is the JavaScript version of processing. There actually are now more and more alternative versions of processing out there. I believe there's a Python version of processing now, and a few other things, but P5.js is by far the most commonly used and perhaps the most useful because, well, one, it's free and you can do it in your browser, in your editor here, that we'll look at in a second. But also you can do really cool things like embedding your sketches into other web pages or really building an entire web page with P5.js. Now what we're going to do today is just do basically convert one of the examples we've used that we've built in processing and rebuild it in P5.js just to illustrate a couple of the differences. There's a lot of similarities to the processing that we're used to, but there are some differences that we'll take a look at. However, before we jump into that, it is good just to note one thing, maybe two things actually. First is, just like on the processing webpage, P5.js has a reference. And so this reference is going to have, just like on the processing reference, all of the functions and elements and classes and things that you have at your disposal. And a lot of these will be very similar, but there are going to be differences as well. So, we see things that look familiar: background, fill, stroke, all these things. But we're going to see today in writing this code that there are some differences. And then along those lines, there are plenty of examples here too that can get you started on certain things like, hey, multiple particle systems, we've done that. Things like that. Arrays, interaction. So yeah, so if you're interested in digging deeper into P5.js, definitely consult some of the examples, the reference, and then there's also libraries just like there are in processing. But we're not going to get into those today. We're going to mainly stick to the editor right here. So here we are. One thing I would recommend is making a free account. You can see I'm already logged in. But what having an account allows you to do is you're able to download and save your sketches as like a HTML page, so you could use that when building a website. But it also lets you embed your sketch. We'll see this later. In the same way you would with like a YouTube video or something, where you can just paste a little bit of code into your web page and your sketch will be running on the web page seamlessly. In fact, that is exactly how I've done our Art22 class page. All the little moving elements on that web page were made right here in P5.js and then embedded into our class's web page. Okay, so let's just kind of get a quick overview of what we got going on here. So right off the bat, we see that we have our code editor, which looks a little bit like processing over here on the left. We've got our console down here on the bottom left. And then over here on the right is where our window will actually be rendered. This is where typically we would call it the canvas. This is where our canvas will be. So if we were just to run this one, for example, we would see we have a 400 by 400 canvas. And we said the background was 220. Okay, so one thing you'll probably note is that this looks pretty darn familiar. We have a setup and we have a draw. Now the only difference is that for P5.js, we make a new function with the word function as opposed to void. So that's just one thing to note. But we can, do things that look very familiar to us. For example, we can say ellipse, how about 20, 20, 20, 20. And let's see what we get. And there we go. We have an ellipse at 2020 XY, which is 20 by 20 pixels big. With the default stroke looks like a black, the default fill of white. And so a lot of the primitives and things like that are going to be very similar or exactly the same as normal processing. Okay, so the example that I want to build today is actually our random walker. So if you remember back from earlier in this quarter, we built a class called a walker as part of our particle system lectures. And I want to build that particular example in P5.js because it's not that many lines of code. We're going to clock it in under 40 lines, I think, today. But it does touch on a little bit of everything. It touches on creating variables. It shows how to use for loops. It shows how to create a class. There's some conditional statements, and there is an array. And so that, to me, that code is a good way just to see what the differences and similarities are between P5.js and processing, because we're going to kind of touch on each thing. Okay, so why don't we do the first thing that we need to get this going. So we're going to build that particle class. So let's first just see how we could build a class in P5.js, and then we'll go back and actually use it. So I'm going to come here to the bottom of the sketch. And just like in processing, when we make a class, we can just say class. And this one I'll just call particle. I'll give us a little space here. Okay, so that looks the same. Now, the version we're going to make of our random walker, and if you remember, our random walker is basically some 2D primitive, we're going to probably use a point today, that has an X and a Y position, and at every frame of our animation, we're adding some offset, or some step size, I should say, in both the X and the Y direction. So it kind of zooms around by it a little bit. So in our classes and processing, we had 3 sections, right? We defined some variables, we had a constructor, and then we had whatever functions or methods. We're going to kind of combine those into a little bit more efficient way to do it. So really what we're going to be doing is combining that variable part and the constructor part into one. So this will be our variables and constructor. So one difference for P5.js is that instead of creating the constructor with kind of our old method where we just use the name of the particle and whatnot, go ahead and consult that code if you need to see it. We actually can just say constructor, curly bracket. Now, what do we want for our random walker? All I really need for this example is we need an X and Y position. That's all, because we're going to add some step size in a bit, but really the only variable we need at the moment is just an X and a Y value. So we can do that with this kind of cool, sort of efficient syntax. We can say this dot X. And let's just say that the initial X value is going to be somewhere between 0 and width. Okay, so that should look familiar. We're just getting a random number between 0 and width. That's the same. Now this is basically just saying, okay, we're going to have something called X for this particular particle. So every particle will have an X. And so this is just how we reference the X value for a particular particle. So in the same way, we'll say this dot Y equals random 0 to height. Okay, so the only difference there is that we're using the this syntax, which is a little bit different, but kind of efficient, which is nice. Okay, so that's all we're going to do in terms of variables and constructors. Basically, we're saying, hey, there's going to be a particle, and it's going to have an X and Y position that's random. That's all we really needed to do to get up and running here. What we do need, though, is a method for displaying the particle and having it add that step size to the X and the Y. So let's see how we can do that. So I'm going to create And this should be very similar to the processing version. I'm going to create a function called display. Okay. Now what do I want to do with display? Well, let's first just draw the actual point that we want to see. So I'm going to say stroke. How about white? That looks the same as processing. Same with this, stroke weight, maybe I want 2. And I'm going to do a point. And what do I want for the x and the y coordinate? We're going to use that same this syntax. So where do we want to point? We want it at the x for this particular particle and the y for this particular particle. Okay, great. All right, so now we need to have the whole idea of the step size, because this is our random walker. So we need to be adding a random number to both the x and the y position. So that should be a very familiar concept because we've built that a number of times at this point. So to do so, we need to add some randomness to x and some randomness to y. So we can just do that right below here. We can say this dot x plus equals. Remember that basically says x equals x plus whatever. And we'll say a random, how about we do a step size of 5? So every particle will be the same. And then we'll just do the same thing for y. We could make variables for this, but just kind of for the sake of keeping things kind of very simple and clean, every particle is just going to have a step size of -5 to 5. Okay. So that really is all we need to get going with our particle. The one thing I am going to add though to the bottom of this display function is that I want to have a check for if this particle goes off of our canvas, just to reset it back to somewhere random in the canvas. We've also seen that before, but let's take a look at the way we do that with P5.js. So because that is a condition, we're going to write a conditional statement. So we're going to have an if statement. So I'm just going to write one long if statement. So I'm going to say if, basically what I want to be doing here is check if x is either less than 0, greater than width, or y is less than 0 or greater than height. So basically if in any direction we are off the canvas, let's reset back to a random position. So we can do that by saying this dot x is less than 0. And if you remember, this is our or operator. So if x is less than 0 or x is greater than width or y is less than 0 or y is greater than height. Okay, make a little bit of room here. There we go. Okay, so this conditional is basically saying, check for boundaries. So if any of these is true, and just only needs to have one of them, then what we're going to do is reset both x and y. So we're going to say this x is equal to random 0 to width. This dot y is equal to random 0 to height. Okay, so this is going to ensure that our particle will always be staying on the canvas. All right, so I'm going to just clean this up a little bit. There we go. You can see that we still have some of the same kind of nice syntax highlighting that we get in processing, where if I click on a curly bracket, it shows me which one is its buddy. Things like that. So that's kind of nice. Okay, so there is our walker particle. We have our constructor kind of elided with our notion of creating a variable. We basically just had an x and a y. And then we use that x and a y to add a step size. And then we check that x and y for if it's left the boundaries. And that's all we need. So let's actually put this particle to use now. Okay, so I'm going to mirror this off of the particle class that we did with our random walker, where we had this idea of a total number of particles that we wanted, and then used a for loop to create that many particles. So first things first, background. I'm going to go with my what has like kind of become the unofficial color for our class, at least on the website. This kind of soft pink blush-ish color. Okay, so we're going to keep that. Let's just make sure everything's running good. So no problems with our class. We got our canvas this color. Great. Okie dokie. So what we want to do is create, well, let's actually just go ahead and create one. Well, you know, we've seen how to do one particle in the past. Let's go ahead and jump right into making a bunch, because really what I want to be doing here is focusing less on how to create particle classes and more on what's the difference between P5.js and processing. So what we're going to do is we're going to create a list of, let's say, 150 particles, and we'll see how we can run that. So one big difference that we're going to see from P5.js to processing is the way we declare variables. So in processing, we would say, like, if we wanted a variable called total that was 150, so we wanted 150 particles, we would say int, right? Because that's the type. P5, as you can see, does not like that. And that's because in JavaScript, we don't actually need to tell it what type of variable it is. P5.js figures that out on its own. What we need to do is tell it that it is a variable. So we just say var. Now there's two ways to declare a variable that can be a little confusing at first, but we could have also said this. We could have said let total equals 150. Let's call it something else, just total 1. So what is the difference between var and let? So neither of them are telling us anything about what total is. Like, we don't know, we're not explicitly saying, hey, this is an int, or hey, this is a float, or hey, this is a string, or something like that. It's just figuring that out on its own. What the difference is something what we've talked about before called scope, which is where in our code can we access this variable. So what I mean by that is currently both these variables are being defined at the top outside of any of these functions. So these are already global variables just by default, because we can use them in any of these functions since they're defined way up here at the top. However, we're going to see in a minute that let is basically a way to declare a variable that is limited to what they call the block. So the scope would be limited to wherever we are defining it. So we're going to be using it for a for loop in a little bit. And so that variable defined with a let, we're going to use it for I, will only be accessible for that for loop, whereas var, no matter where you define it, is a global variable. So you can use it anywhere. So let's stick with var for now, because total is going to be something that we're going to be using in, perhaps wanting to use in multiple places in our code. Again, by default, we already have that because our code is just on one page here, and we're defining it outside of any function. So it's kind of global by default, but probably a good practice is to use var. So here's what we're saying is this is going to be the total number of particles that we want. So total number of particles to create. Okay. Now, just like in processing, where we created that array list to contain all of our particles, we're going to do something very similar, but in the same way that our constructor was a little bit more efficient here in P5.js, the way we create that list is also going to be a bit more efficient. So in this case, instead of that really crazy syntax of all that for array list, all we have to say is var plist. So that's going to be our list for particles. and that is going to equal just an empty array. So this is kind of a lot nicer, right, than writing that whole long line for array list. So there's a little bit more flexibility that we get in JavaScript that's kind of nice. So we're going to say create an empty list for particles. How about empty list to contain particles? Great. Okay. So now what we're going to do, we're going to come down to our setup. And if you remember from the random walker or other particles of the past, what our process to create them, what we did was we used total as part of a for loop, and within that for loop we create new particles and add them to our plist. So let's see how we do that in P5.js. So the loop itself looks pretty similar. We're going to say for. Now instead of saying int I, we now know that we can just say let I equals 0, and I is less than total I plus plus. And then we'll do our parentheses and curly brackets. So this looks the same, right? The only difference is this let instead of int. But everything else, the semicolons, the syntax, all that holds true. Okay, so now what we need to do is, so we've created a loop that's going to do 150 iterations, because we're going to go up to 150. Now what we need to do is create a particle and add it to the plist. So here's how we can do that. We can say plist dot, so instead of in processing where we had add, we're going to say push. That's the syntax we're going to use for P5.js. So we're going to say push a new particle. One more parenthesis, and there we go. So yet again, we have a slightly more efficient syntax to get that done than what we were typically doing in processing. So this is add, aka push, new particle to plist. There we go. Okay, so that is what this line is doing. So now what this for loop has done is said add 150 total new particles to plist. Excellent. Okie dokie. So now we should actually just draw something, right? So we are going to use, so in the past what we've done is we created another for loop, and as we go through that for loop, we say get this particular particle and run the display function. And we're going to do the same thing. So we're going to do another for loop. We're going to say for. Once again, we'll use let instead of int. So let I equals 0. I is less than. Now what we want to do is we want to make sure we go through, have this for loop go through all of the particles in our plist. So we can say plist dot length. That should look familiar. Exactly how we do it with arrays in processing. And now I plus plus. Okay, so I'll say loop through plist. Okay. Now what do we want to do once we're looping through the plist? We want to call the display function. So the way we're going to do that is we're going to say plist, and now we're going to use our I as the index, just like we do in normal arrays. That should be very familiar looking. So plist I, so get that particular particle in the plist, and have it run its display function. There we go. So run display for each particle. Okay. Let's see what we got. Hey, there we go. Okay. So we can see that we have 150 particles. As they bounce off the screen, they're presumably getting reset here. That looks to be the case because it seems like we're keeping a consistent number of particles. And that's really pretty much it. The main differences we saw here were the way we declare variables between this var and let, but not using things like float or string or int or all that good stuff. Some slight syntax changes, right? Like create canvas instead of size, function instead of void, a couple other small things. There is a way to do this in processing, this syntax. It's hard to say, but yeah, a few differences than processing. Now, if you've created your account, what you can do is not only save your project, but you can also, where is it? Share. You can see now that you could go to embed and basically copy this just like you would a YouTube video and embed that somewhere and just paste it into, if you have a blog or website or whatever it might be, you can have your sketches running on your web page. And the cool thing is, because it's linking back to the saved projects you have in your P5JS account, you could come back and make some changes, and it's going to reflect those changes on your website. There's some formatting things you can do that make it look a little bit nicer. That yeah, let me grab those real quick actually. Okay, so what I'm going to do here is show you the difference between the default copied the clipboard, great. Okay, so by default you get, when you get the embed link, it has the iframe. If you've done any HTML, you know that that's a very common way to embed things. And then the source is your sketch, and that's all they give you. Now you can add a little bit more to it to make it formatted more nicely. So one thing I do is, first of all, you can just set the width and height of your the canvas you're embedding. But more importantly, you can do this next couple lines: the overflow hidden, scrolling no, and frame border 0. And what that's going to do is, by default, when you embed your P5JS sketch, it's going to have some things that personally I don't like to have, which is like there's a border around your sketch, and a couple other things that don't make it fit seamlessly into your web page. So by adding these extra components, you get this kind of seamless integration into your web page. So if you've seen our class homepage, and I have a random walk particle system running at the top of the page, it looks like it's just embedded cleanly into the homepage there, and that's because of these extra arguments given to the iframe tag here. So just good to know if you are embedding and you want it to look a little bit nicer. Okay. All right, everyone. So that is a very quick overview of P5JS. It's a very deep topic. You could really build a lot of web-based things with it. It could be a cool idea for your final project. But if you have any questions, of course, let me know. And for your coding activity, I'm just going to ask you to take one example from earlier in the class from a processing sketch and convert it into a P5.js sketch just to get practice with that. All right, everyone, good luck, and we'll talk to you soon.